Now, this is just a warm-up, and I was trying to give you a problem that you might be able to solve while deriving something with respect to t for your first time ever. So here you go. This is just information that I gave to you. Here is the equation I told you to take the derivative of, and I told you your goal is to find dA over dt. So, here we go. Alright, so how are we going to get this? Let's see. Let's start with the a. Now, I know we're taking the derivative with respect to t, but this is just like when there was a y and an x. You guys remember when we did the implicit differentiation? Mm-hmm. The y and the x? Okay. This time we're taking the derivative of a. Now, what is the derivative of a? Let's go with Ryan. Go ahead, tell me what the derivative of a is. Yeah, it's just 1. Good job. Okay, now a is not what we're taking the derivative with respect to. We're taking the derivative with respect to t. And so, what do you have to do after you take the derivative of a? You remember the chain rule? Do you remember the chain rule, Ryan? So do you know what you're supposed to multiply this by? A prime. Supposed to multiply by a prime. Now, I'm going to stop using a prime. I'm actually going to write something different. A prime, people, equals dA over dt. It's the same thing. Okay, so I'm not going to use a prime anymore. I'm going to use dA over dt. It's time to grow up. Okay, calculus students? I know you guys don't like dA over dt, but I'm sorry. It's time to get real. Okay, so then we have our equal sign. So we have the derivative of a, which was 1, and then we have to multiply it by dA over dt. Now, why do we have to do that? Well, the chain rule says we have to do that. We have to assume that a is a function of t. Remember me saying that before? It's kind of weird. I don't know if you've ever heard anything said like that before. But inside of a, we have to assume that there's a function of t. We don't know what it is. But it could be something like this. T squared plus 1. See, that would be a would be a function of t. But we don't know that, so I'm not going to write it down. We just know that we're going to have to use a chain rule and write dA over dt. So now we got the other side. We have pi r and then squared. Oh yeah, here's a good question. How many variables do you guys see in this equation? Let's see. Let's go with Kevin. Kevin, how many variables do you see? There are 2 variables. Do you know what our 2 variables are? You guessed 2? Come on, dude. You don't know what the variables are. You're looking at this equation, and I say, what are the variables, and you have no idea. A and R? You're saying that A and R, these guys are the variables? You're right. How come the pi is not a variable? Because we know what that number is. Pi represents a number. It is not a variable. So there's no product rule here. If you try to do a product rule, kudos to you, but you don't need to do it. Now, if you do the product rule, you actually should get the same answer, but if you're not treating this like a number and you're treating it like a variable, then you probably still would get it wrong. But anyways, all right, Julia. So if pi is a constant, that's like a number. It's like a number 5. And we just have the r right here. What would the derivative of r be? Yeah, r prime. That's right. But what's the grown-up calculus way of saying r prime?
dr over dt.
Yeah, there you go, dr over dt. Now, all these are multiplying to each other. We have 2 times pi times r times dr over dt. We get r because we subtracted 1 from the 2, so it's really r to the 1 power, but I'm not going to write that because that looks like r prime. All right, so this is what we got. And actually, we could clean it up just a little bit by erasing this 1 right here. All right. So there you have it. Do we have a definition of dA over dt? Yes, we do. So we're getting closer to finding out what dA over dt is. So, but this isn't your exact answer. Do we know what r is? Yeah, it's 24.5. Do you know what dr over dt is? Yes, it's 5. Okay, so this is what we get. We have dA over dt, and we're going to plug in that stuff. We're going to plug in, actually, let's just do it like this. We got r, which is 24.5, and then we have dt, or dr over dt, which is just 5. And then so we're going to go 2 times the 5 first, because it's all multiplying, so we can change the order in which we are multiplying them. And so we have a 10. And what is 10 times 24.5? Just move the decimal. 245. And then we have pi. That's it.